Okay, so we kind of have an interesting one here today. We have a Lowrance HDS12 Gen 3 with NMEA2000 transmit errors. So we have it apart already here. Did visual inspection, everything looks okay. Now in order to troubleshoot this further, we obviously need a backbone and the correct cabling. We don't have any NMEA2000 cabling in the shop, so what we're going to do is we're going to make some. So we took some connectors and we lubricated another NMEA2000 connector we have, and we fit them in there. We used some hot glue and we just made a connector. It's going to be fine for our purposes here. Just make sure it fits okay. Look at that. Beautiful. Perfect. So we need two connectors. We made two because we're going to have just a simple system here. Took a piece of Cat 6. We're going to wire each one of these to the same colored wires, and midway through we're going to use our white and yellow I'm sorry, our orange wire and our white orange wire as our data wires, and we're going to wire a 60 ohm resistor in here across both data wires. That's going to act as a terminator. That should work just fine about midway through. Then what we're going to do is we're going to connect this guy up to a known working unit. We're going to try to get some NMEA2000 communication between the two, and we can go ahead and troubleshoot further from there. So we're going to get this wired up, and we'll get right back. Looks like we need to reorder some resistors, but instead of 60 ohm we found 120 ohm, and what we're going to do is just put them in parallel, which is going to be good anyway because these are only quarter watt. So we put them in parallel. They can dissipate half watt. So that's good. We're just going to sort of twist them together here. And we're going to solder them onto these two data wires. So what we did is we did some Googling on NMEA2000. It's fairly documented. And we found some pinouts for Garmin and some other units. Just using a meter, we found and located a 12 volt pin. In fact, the 12 volt pin on the NMEA connector is going to a 5 volt regulator on the board. Because I assume the NMEA circuit on the board requires 5 volts, and you apply 12 volts on the NMEA backbone, which feeds into here and obviously powers the 5 volt circuit via the 7805 regulator. So anyway, we figured out that on the Lowrance systems, the top pin is shield, which actually isn't used in our case. Left is plus 12, bottom is ground, center is CAN L, and right is CAN H. NMEA2000 is actually a CAN network. I don't have the specification. In order to get the specification for NMEA2000, yeah, I think you have to like apply for it. It's very expensive. I don't know. In any case, it's not an open spec. So okay, let's get going here. Obviously the best thing would be to have the proper cabling, but we just don't have it here. If we get some more NMEA repairs coming in, we'll order some cabling. But for now, this should work just fine. And it kind of lets us learn a little bit more about the NMEA2000 system. So it's good. So I'm fine making this because we learned something and we're getting a useful cable out of it as well. So it's good. Perfect. Perfect. So I got some of this plastic dip stuff a while back. Stuff works awesome. I'm actually gonna use it on this here, and then I'll probably throw some heat shrink tubing over top of that. Okay. We're gonna go ahead and let this dry, and then we'll start wiring our connector ends on this wire. Okay, now we have a short NMEA2000 cable here, and it's internally terminated with a 60 ohm resistance, which is actually 220 ohm resistors in parallel to create our 60 ohm equivalent resistance. Those are just attached across the data lines. So let's see. One thing I forgot to do is we got to put 2 wires coming off the red and black here, because we need to power our NMEA2000 network. We need to power it with 12 volts. So forgot to do that. I'm going to splice a couple wires on here for connecting to our power supply. Okay, so now we have our 12 volt power coming into the NMEA cable. So we should be good to go now for testing this unit. As far as just testing and troubleshooting this unit, this cable is going to work just fine. Obviously, if you're going to have an install, a long-term install, it's probably better just to buy the cables. Maybe a starter kit and then go from there. But this is just very short term, quick thing. We needed these in a pinch, and we couldn't wait for them to come in. So we just went ahead and made it. Like I said before, we'll probably buy some proper cables if we do get more NMEA issues in. We get very few NMEA issues in. We've only had a couple units with NMEA problems, NMEA2000 problems. It is not the older sort of legacy NMEA system, but this NMEA2000. Okay. Just strip these wires, tin them. That way when we're ready to test, all we got to do is throw some alligator clips on here, some test leads, hook that right up to our 12-volt supply. Sort of bend these over, make like a little eyelet. We'll give the clip leads a little, something a little bigger to grab onto. Otherwise this thin gauge wire is sort of tricky to have the clip lead stick onto. They tend to just slip right out. So if you put a little loop in there and then tin it, just gives a little more material to grab onto. Just like that. Okay, we're gonna let this dry a little bit. We just used some of this Plastidip stuff. Oh, let's see, there. So it takes a little bit for the stuff to dry. We'll probably throw a little bit of heat on there just to speed up the drying process. Then we'll throw a little bit more of the Plastidip on there just to make sure we have some good insulation back on those wires that I cut and burned off. And we'll see if I can find some large heat shrink tubing to kind of go over this again. I think I used up all my larger diameter heat shrink tubing, but we'll see what we can find. This Plastidip stuff works great, but it is pretty messy. But it is good stuff. You can use that. It's actually, I think, made for making handles, things like that, but it's a good insulator. Making handles like this. Just did that as a test. See how it work out. Works obviously great. Okay, we're gonna let this fully dry, and we'll get right back. Okay, we have the HDS12 back together now. Put the board back in. Our cable is all set, ready to go. We have our 12-volt power coming in to the two power wires on the NMEA2000 bus. This is our small bus. Little self-contained bus here. Bus and I guess it'd be 2 drops. I'm not sure what you'd actually call this, but there's the terminator in the center, 60 ohm terminator. So we should be good to go. We're actually going to have to fix another unit here in order to test this with. So we're going to set this aside for now. I'm going to get something else on the bench, repair it, something capable in NMEA2000. Then we're going to try to link those two guys together. And then we'll see if we're getting errors on this. I'm assuming we are, because that's what the customer reported. Once we confirm the errors on this unit here, then we'll proceed to troubleshoot this board, figure out what the problem is. Could be something as simple as bad connection, could be something more complex. I'm leaning towards probably something more complex, but we won't know until we start troubleshooting. What else? Did some more research on NMEA2000 protocol, and as I mentioned, it's closed source, and you actually have to sign. You have to pay some large fee or something in order to even get the protocol description specification. I'm not too sure how that side of it works, but there has been a number of people that have done some awesome work reverse engineering NMEA2000 protocol, and apparently there's all kinds of open source software out there to hop on the NMEA2000 network, and you can collect messages and data and stuff like that. Probably going to play with that in the future. Maybe set up a Raspberry Pi. There's actually some companies that make shields where you can connect to NMEA2000 networks via the shield, which makes it super simple, super easy. But it's basically just a CAN network, just like similar to a car. Has a CAN bus. NMEA2000 is a CAN network, so very similar. So there is information out there. I guess it's not completely custom. So the protocol layer itself is custom for NMEA, I guess, but on the hardware level, I guess it's just a CAN network. So anyway, we'll get back as soon as we get another device fixed that we can test this unit with, and we'll be right back. Okay, might be kind of loud. We're milling a custom circuit board over there, so apologize for the noise. Just want to do a quick update. We fixed another unit here, different customer, HDS7, works awesome. So now we have a unit to test this unit with. We did check, and we are getting transmit errors. It says under diagnostics, transmit error errors 255 and no receive. So obviously the CAN communication is broken on this unit, just like the customer said. We were looking around the board trying to figure out how the CAN bus works here. The processor is capable of direct CAN communication, I guess, with some modifications. I'm not sure if they did that to the CPU card or not, but some more investigation. Obviously, we want to focus around where the NMEA2000 connector is, and there's a small chip right here, and give me a quick sec, and there it is, high-speed CAN transceiver. Awesome. So okay, so we're narrowing down our search here. Now we know what chip handles the CAN communications. So we're going to check this chip here. We're going to take a good look under the microscope. We have some parts units we can salvage a chip off there. And we're going to kind of dig into this data sheet. This is like a gold mine of information, which is going to help us understand how the HDS12s communicate with the NMEA2000 network. So I'm going to dig into this. I'm printing it out right now. There's a whole bunch of pages, and I'm going to study this thing and figure out exactly how this thing works, and then we'll get back. Actually, just kind of reviewed the last bit of video we did, and notice I made a mistake. This is not the CAN transceiver. This is a dual digital isolator. Not the CAN transceiver. I have a data sheet for this chip as well. This is the CAN transceiver. The what is it? 30. Yep. 3660 CAN transceiver right here. Makes sense because this is a 5-volt regulator. What is it? An LM 78M05. Yeah, so it's a 5-volt regulator. Makes sense because it's taking the 12 volts, coming off the bus, converting it to 5 volts, which powers this chip and the CAN system on the board. So I also found, just by basically investigation and visual inspection and things like that, and more research into the processor, that the processor is acting as the CAN controller, the CAN protocol controller, and this chip is purely transceiver. So it seems that this chip is probably directly tied, the receive and transmit lines on this chip are directly tied to some pins on the processor card itself. So as far as troubleshooting the NMEA system, I mean, the first thing we're going to do is connect power 12 volts to the NMEA2000 connector, you know, via the cable we made. We're going to check to make sure we have proper input voltage here into the 5 volt regulator. Should be about 12 volts. Make sure our output is 5 volts. Make sure we have our 5 volts coming into this chip here, the transceiver, the 30660. From there, just make sure we have good grounds, which I'm sure is an issue. And then if all the voltages seem okay, I would say that, you know, it could be a defective transceiver. So if you replace the transceiver, I think that's pretty much all you can do, aside from you know, trying a different CPU card, because from my understanding is, at least this is how I think it works. NMEA connector supplies 12 volts to the regulator. Regulator supplies 5 volts to the transceiver. Transceiver is directly connected to the CAN high and CAN low on the bus. And then there's a receive and transmit line on the chip that I believe, again, I think, I need to do a little more research, goes to this digital isolator. So the transmit and receive lines, because this is a dual digital isolator, and there's a transmit and receive line, so it makes perfect sense that both of those lines would be isolated to further protect the processor, I'm guessing. So transmit and receive lines go to the digital isolator. The output of the digital isolator, well, the input and output, I suppose, goes directly to the processor, I think. So if the transceiver is good and the digital isolator is good, and obviously there's connectivity, so the socket's not bad, it would lead me to believe that it's processor related, so which is worst case scenario. So that's what we're going to do. We're going to make sure there's proper voltages here. We're going to check voltages on the transceiver, maybe check out the input and output, the receive and transmit lines on the scope. Follow that over here to the digital isolator, make sure those receive and transmit lines are still here and still on this side. And from there, I mean, that's about all we can do, I guess. If it's still not working, we'll try a new CPU card, and that'll sort of narrow down the problem. So, alright, we'll get to it and be right back. Okay, so we checked the CAN transceiver on the 12 here, and we are getting 5 volts to the transceiver itself. So what we did is we just went ahead and took a transceiver off of a parts board. I think it was HDS9, doesn't matter, same chip. So what we're going to do now is see if that resolved the issue. Hopefully it did. We're going to go into our HDS7 reason for testing here, go to network, device list, refresh. I do not see it here, so it looks like it might not have fixed the issue. What we also did is we took the CPU card out of this 12 and we put it in another unit that was having CPU card issues, and we were able to see that HDS12 on the 7 in the device list, which means the CPU card is not the issue here. So we've narrowed down the problem to, well, we've chipped away at one of possible issues, which was the CPU card. We don't believe that's the issue here because, like I said, in the other unit, it showed up in the HDS7. So it has to either be the transceiver or the digital isolator, unless there's some other broken trace or something on the board that we're not seeing. So we're still not seeing it here. So the replacement transceiver did not resolve the issue. So I'm going to go ahead and shut both these units down. I'm just going to go ahead and replace the digital isolator and see what happens, and then we'll come right back. And there we go. Awesome. Okay, so we replaced the dual digital isolator, and boom, came back to life. We have the HDS7 listed here in the device list. We have the HDS12 Gen 3 listed here in the HDS7 device list. Now, it's definitely possible the transceiver might have been bad as well. So I'm going to say for future use for me personally, and it even says there's a software update available on the network. Jeez. Awesome. Let's just get out of that. What was I saying? Yeah, so if the buffer was bad, it leads me to believe the transceiver, not the controller, the CPU access of the controller. The transceiver might have been bad as well. So I would say if it's going to be replaced, replace them in pairs, the transceiver and the buffer, because if the buffer was bad, right, and we know definitely the buffer was bad, I mean, we can check the transceiver by taking the old transceiver off the donor, back off, putting it back on the original transceiver, seeing. But if the buffer was bad, which we know it was, it leads me to believe the transceiver was probably bad because something took out the transceiver. And if it took out the transceiver, there's a good chance it probably took out the buffer as well, because the buffer's purpose is to protect the processor. So I'm going to say bad transceiver, bad buffer, both bad. Replace them, and we are good to go. So we learned a bunch about CAN networks, which we didn't really know before, and that not only applies to NMEA2000 systems like marine use, it also applies to automotive CAN systems, because when it comes down to it, it's all the same stuff. NMEA2000 just communicates at a higher level differently. There's different codes and things like that. So the protocol itself is different, but the hardware level is the same. I mean, they're using an automotive CAN transceiver in these units. I mean, it's the same stuff. So this knowledge we sort of gained here can be applied not only to fish finders and mobile stuff. It could be, applied to car stuff as well. So yeah, so we're done here. This is awesome. Customer's gonna be super happy. He's been waiting a while. Normally we try to get stuff out quickly, but this customer's been waiting a little while. He's all the way in Japan, so we got to switch the language back to Japanese for him. And get this shipped off. I have no idea how long it'll take, but it got to us fairly quickly, so hopefully it'll get back to him quick as well. If anybody has any NMEA2000 transmit errors, any issues with the NMEA system, or any fish finder issues at all, we work on not only Lowrance, we work on Garmin, Humminbird, all the fish finder manufacturers. We also work on all electronic devices, not just fish finders, although we do like working on the fish finders. If you have any questions, if you want to get a free estimate, go to www.rudolphrepairs.com, click on the free estimate or click on mail in, and you can send your stuff in to get fixed or get a free on bench estimate. You can get us at 1-800-517-9101. Email is probably the fastest, rudolphrepairs@gmail.com. All right, guys, I'll see you in the next one.